Could you run it again? Could you run it just one more time? So satisfying. All of this runs right in the IDE.
Save to
Yeah.
GIF. I've read a comment.
Yep.
Let's save it to GIF.
Sure. The best way to explore interesting algorithmic problems with interactive code and with visuals is Kotlin Notebooks. My colleague Roman is about to show you why. We're solving Advent of Code 2025 Day 4 by writing Kotlin code in an interactive environment. And we don't just want to solve the problem, we really want to push our ability to explore and understand. So let's go on that journey. Roman will guide us.
And let's bring it here. And here we are, printing department. So here we can read the description one more time.
The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. How many rolls of paper can be accessed by a forklift?
Copy input and put it here. And string, of course. Wonderful. So the first thing I actually have in mind is it's some 2D array. And every time I see 2D array, I hate that we actually do it in Kotlin. Because working with 2D arrays in Kotlin, not that pleasant as in some other languages. But it's all unless we use Multic, a wonderful library for n-dimensional arrays. So Multic is kind of NumPy, exactly.
Yeah.
NumPy, but in Kotlin. The good question should be how to create something in Multic. As far as I remember, there is a kind of like in NumPy, something like K or something. Yeah, MK,
Yes.
and then you can create an object by creating ND array. So for example, ND array can take array and then it will return you D1 array, one-dimensional array. If I need two-dimensional array, then it should be a list of lists.
Ah.
Okay, so let's prepare this. Okay, so I just will map it. Then map okay, so we're gonna have rows. We're gonna map it to, it's gonna be double. So if it's, okay, let's say it this way, then it's gonna be 0, else, okay, let's make it double, 0, otherwise 1. I'm not sure if we need, in that case, territory here. Yes, we did it. So now we have the original input as a multi-array. Hopefully it was the hardest part here. So then probably we don't need this type array as well, I guess, and most likely probably we even don't need this one. So what we're going to do next is actually we need to calculate the number of toilet paper rolls around each cell, right? But it's actually convolution, right? With a kernel with all unique, with 1/9 in each cell, 3 by 3 kernel.
Yeah. We're moving a grid over the thing, yeah.
Okay, anyway, let's do it. So that shouldn't be hard. So we're gonna create a new array for this, right? So let's call it result. It should be MK zeros of size. Okay, so it's gonna be double, and it should be the same size, right? So dimensions, kind of input array shape 0 and array shape 1. So, and we need to go through all the rows and columns, and inside each row and column. Okay, yeah, that should be easy. So for E in 0 to, let's probably create some value for it, calls. So rows and for, oh yeah, now it works. So yeah, inside this we need to calculate the sum around. Yeah, so okay, let's call it var sum 0 for delta I in from -1 to 1, the j in -1, 1, sum if basically write the following thing. So like if we have the index inside valid indices, we need to calculate, because yeah, so here input array, else 0. Okay, so it should be a double, I guess. Nope, it's still.
And you should also be returning 0.0 in the other
Yeah.
case.
And probably in the end, we need to, yeah, that's something strange. So let's take this sum and divide it by 9, right? So, and then we get basically what we need. Let's see. What is important is that we have index out of bounds, which is a problem. Why? Because we probably need until here, right?
That sounds reasonable.
Yes. And we have a wonderful visualization here of our array, which is weird. So let's visualize it like somehow, like visually, right?
Yeah.
So for this, we can, for example, convert our result buffered image, which can be displayed by a notebook. What I know about buffered image is that I don't know its syntax at all. For this, I'm gonna use AI.
Okay.
And say it's not a part of solution, I believe.
Yeah, exactly. We'll allow it here.
Convert multi-array to buffered image. And so it's generated something. Okay, so okay, now we have result to buffered. Amazing, it looks really great. So for this, I think that we need to have a follow-up message, add cell size param. So what I love about it is that like it's instant, like we can instantly check what is generated. Here we are. So now we have a blurred image. And let's check, yeah, and the outer border looks darker than everything else, which is quite natural, because like
that makes sense.
So okay, great. So we can accept this, and probably we can now extract this one as a function, because like it looks like it should be a function. We can do it with AI as well, I guess. Let's probably try it. I never tried.
Sure, why not?
Extract blur function. And what is great, it shows the diff right in place.
It's also quite amazing that it continues to like use the notebook
My
syntax.
code.
Yeah, like the structure still looks great.
Yeah, now we have it as a function, and it still works. Yeah, cool. And okay, accept it all. So fast. So okay, I will delete this one. I don't like when I have too many things here. So okay, now we have a blurred image. So can we check the oh no, we can't. Like the problem is that we can't see what are the values here, which is not good. So what if we can convert this image into some more interactable format? So for this, we can use, for example, our wonderful Candy library that can create it like in interactive way. Or, given that we are in notebooks and we are in IntelliJ IDEA, we can try another feature. Like notebooks can present the results of Swing type as a part of interface.
Okay.
So let's try it. Yeah, first like let's write it probably. Of course, I like the only thing I know about Swing that I don't know it. So again, I'll do it with Claude and say convert a multi-array to JPanel. That's the only thing I know. With interactive mouse over showing the value to interactive panel. Yep. And yeah, here we have some frame, whatever. We don't need it. Like, I mean, we can just take results to interactive panel. That's basically it. This is the result, because like the size of this panel is kind of 0 now. So like we probably need to put set size here. So example, like this. Cool. Now we have this. But the problem is not interactive. It's not interactive because like we are currently, like we can't add jpanel into IntelliJ process now. Like we are running in, like the UI is running in IntelliJ process. So that's why we need somehow to add it. So for this, we can run the project notebook in IDE process. So like I'm gonna accept it. I run it in IntelliJ process, and it's gonna say me, please shut down this session because we need to restart the session, like because it's a new process. Okay, let's restart it and let's rerun it all. Oh my gosh.
That's incredible.
What I love about this approach, I actually don't really, I shouldn't really read this part. That's basically, I'm okay with the result because it looks pretty much similar to what we had here, right?
That's so good.
Great. Now, what should we do? We need to calculate the number of rows which are okay. So now I need to take the rows which are smaller than 4 divided by 9, right?
Yes.
Because we calculated it all together. But what is also important, like I should somehow skip empty parts as well. So like probably here I need then mask it by multiplying it to input array, right? So now I multiplied it. Now I have only the rows, and now I need to take only the rows which are smaller than. So like let's map it and take only the rows which are like if it's bigger than 0 and it's smaller than 4 or 5. 5. Do you remember? Because like we didn't exclude.
We have one in the middle. Yes.
The one in the middle, yeah. So it's gonna be 1.0 else 0.0. Oh, here's the result. And yeah, we just need now to count more than 0. So here's our answer. And if it's correct answer,
yep,
13.
It's 13.
Great. So it's time to play with real input. So we had an input here. So let's our input is today. Yep. Now recalculate it. Input array. There's some helper functions.
Mm-hmm.
And actually, here's our solution, right? So like, for example, oh my gosh, it's a blurred image. Okay. No, 10 even big. Yeah. Looks like snow, right?
Yeah,
That's
it
why
does.
It's advent of code. So, and here we are. So like we now can probably, right. Oh my gosh, too big. How was it? 5. Yeah. Some results. I don't know. Like, okay, let's just try it. So here's a result. Let's try to submit it. Today, submit part 1. Copy. Da-da-da-da-dun. Oof.
Congratulations. Very cool.
So what should we do next?
I guess we'll need to find part 2 and find out.
Today, view part 2.
Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklifts might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the owls remove if they keep repeating this process?
Yeah, so we can do more or less the same thing. Then we just need to run it one by one. Like, I mean, like step by step, and remove it and remove it and remove it, because like we have the result for the previous one, and then like we can just remove it in a cycle. Let's return back to the test input and rerun these two, get this input array. So what do we have right now, right? So we actually can get the interactive panel, cell size 30, guess. Yeah, here we are. So, and we just need to do it in a cycle now. While, I don't know, some while, like either while here or there, like we're going to decide it later. And we just need to say that we have current, which is input array. And instead of input array, now we're going to use current, like, and we need some result to accumulate the result. Now we have a clash here. Okay. Well, I don't need this variable at all. I think like it's okay to use just this one, current blur. Now we're gonna have to remove here and take, and that's gonna be the one which I want to remove, right? So now to remove count, good. Yeah, like this. And I should do it while I can remove something, right? So I will put it into some variable like to remove count. And I do it while there should be do. Yes.
There we go.
Yeah, because, yeah, you're right. Let's try to visualize it, because like otherwise it seems we can lost what's going on. So for this, we can display the original. It was current, right? And we want to update it on each iteration. So like we can actually mark the display result with some. Okay, let me explain how it will work. Like I can display the current. Okay, to interactive panel, cell size 13. So here's a original image, and then I can update it on each iteration. So we'll update display, and here I need to show basically the same thing here. And let's run it and see how it all works. Whoa, we have two of them, like the one before and one after. Probably I need to add some thread sleep here. Mutable array. So I actually spoiled my initial array with it. So for this, I will probably make it like this. So I will create a new current and say that current is a current minus to remove. And here we go. And if I run it second time, yeah. Do you follow?
So yeah, that's so cool. That's very, very nice.
We need to check the results. So what is the result then? 43, and
that's correct.
Could be 43. Oof. Shall we try it on the original one then?
Let's give it a try.
Then I'll take this one, recalculate these three, and probably I need to join it finally. Oh, merge cells. Yeah, there. Merge with above. Okay, great. Yeah, recalculate it. So the problem gonna be that 30 is not the right one. No, it should be 5, right? So 5 and 5 here. And let's rerun it. Oh my gosh, it's so beautiful. It's so beautiful.
Wow.
And it looks like, I don't know, like how it looks like. Oh, it's still going. Yeah.
That's so cool.
And the result is, let's check it. They submit part 2 result. And it's correct.
Amazing.
Oh my gosh.
that was, what an amazing journey, really. That was so cool. I mean, I also solved the problem earlier this morning, but I never got to appreciate like its visual beauty. Like that's actually, it's really gorgeous.
It's really beautiful. This one, by the way, this one looks like my calendar for this week. This one, looks like, I don't know, like it's similar to game of how's it called, like
Game of Life, yes, Conway's
Game of Life. Yes, exactly. Game of Life. Oh, it's really beautiful. I love it.
Very nice. Could you run it again? Could you run it just one more time?
Yes, sure.
Ah, so satisfying.
By the way, what if we make the delay smaller here? Like, for example, 10. Are we done? And
Ooh, so
yeah,
organic,
it's
so
better.
quick. I love it. And the fact that all of this
Oh my
runs.
gosh. What's the
Whoop.
fuck is going on? Yeah, that's the beauty of
The fact that all of this runs right in the IDE and you render it out as an interactive panel still, like where you can hover over things and you can inspect the individual values. It's really mind-blowing. Like, it's an incredible way of working with a problem like this.
yeah, that's why I love notebooks, because it's interactive, it's visual, it's perfect for making demos, and yeah, the possibilities are mind-blowing. So like we can do whatever we want to do. Save to
Yeah.
GIF. I've read a comment.
Yep.
Let's save it to GIF. Should we?
Sure.
Yeah.
I mean, if you can create one buffered image, I'm sure AI can write the code to wire them all into a GIF, right?
Let's do it this way. So like we call it steps, and it's gonna be a list of buffered image. Steps plus current buffered image. So let's run it again. So let's wait. Yeah, it seems we are done. So let's take steps 0. Okay, it seems it works. Steps 4. Yeah. So, and now we're gonna ask AI to help us, of course. Convert steps to GIF. I'm not sure if there's a standard library function for creating GIF, but hopefully that's something weird happening. GIF file. Okay, GIF save to GIF file absolute pass. Okay, let's run it. I don't know what's going on here. Create from buffered image, which is unresolved. Unresolved.
Now it's a rendered image instead of buffered.
Okay, so read-only file system. Word. Let's continue. I feel myself like an agent.
Does the AI see these like inline stack traces as well?
Should be.
Very cool.
So, oh, at least now it works. Yes. So, and it even added, okay, accept it all. Cool. Like that's a pretty thing. So it's actually included it as a HTML thing here. Okay, but now this base 64 GIF is output, close, GIF writer. Where is the file itself? Ah, okay. So it decided, okay, the file system is read-only. It decided to write it this way.
But I mean, that seems perfect.
Like save. Oh no, I need to save on disk. Users from
yeah.
Yeah, it works now. Let's see. And indeed it's animated. So I guess it's
cool.
Then I think it's time for Twitter.
Yeah, it's ready, right? It's ready.
Should be so. I guess so. Yeah, so guys, if you never tried Kotlin Notebooks, you're probably it's try time to play with it. Because yeah, it's a huge fun to play with it in the IDE, and it's a huge fun to play it with Advent of Code, because like it looks awesome and it feels awesome.
It's really so great. That was I could not have come up with a better demo for Kotlin Notebooks than this. Like it is mind blowing. Going from we'll parse a little bit of input to we'll turn it into a multi-dimensional array to we'll whip up a quick visualization first as a buffered image, but then we can also run it as interactive in the IDE process. And then, of course, yeah, for step 2, like being able to just have the iterated version that animates, it's gorgeous, it's fluid, and I'll be honest with you, I'm still a little bit mind blown that the AI integration in IntelliJ also just managed to not just produce the GIF, but also figure out, hey, I can display this GIF as base 64 right inside the IDE, inside the notebook as well. It's so many pieces all coming together like perfectly, and that's really, really cool. Thank you so much, Roma.
It's always my pleasure, and like I'm pretty happy that today's task is that much like suits Kotlin notebooks and visualization and all of those things, because like yeah, I mean, like they just like, because for example, previous task was not that visual, I would say, because like we have again a perfect match.
Yeah, we really got lucky with this time again. Yeah, this was lovely.
In the end of the day, like, and you always can create gist. It will create your notebook, and if I click on it, it will create it. I'm gonna open it right in browser. So here's the task. Here's our solution. Here are all the images. Here's the task number 2. Unfortunately, it's not interactive, obviously, but it's still like until we open our GIF. This one is interactive. So now you can easily share it with anyone. And what I love with like AI is definitely transforming how like we write code, but like AI and Kotlin notebooks, like it's a perfect playground. It's way better than like jumping between ChatGPT and your ordinary Kotlin file. You can just like make it simpler and faster.
Amazing. Quite frankly, Roma, I have nothing to add, and nothing can follow this. So, yeah.
And I think that like Maltic helped us a lot. Like it was very intuitive to use it, except like creation of the array itself. But overall, it feels like ordinary two-dimensional array.
Yes.
And with all these operations like minus, multiply, whatever.
To find disclaimer, while we did use AI, I want to be very clear, we did not use it to solve the problems. The problems, that was our brain cells. It was the visualization where we outsourced to AI.
Yeah, just like people are not like created for remembering syntax of buffered image and swing.
Yes. We're here to solve interesting problems.
These two are absolutely outdated. Our brain is actually intended to solve problems about rolls of toilet paper. That's the intention.
Exactly.